reducing excessive gas cost in unwarranted situation and enabling new use cases for contract storage will be helpful to smart contract developers. Till date, the use of transient storage is severely limited. If you want to learn about proposed transient storage opcodes and what it brings to the Ethereum mainnet, continue watching. Welcome to PEEPanEIP episode 91, a series dedicated for overview of proposals and protocol upgrade features. I'm your host Pooja Ranjan. In this special episode on Shanghai EIP, we will learn about EIP-1153 Transient Storage Opcode with Moody Salem. Moody is a smart contract developer and is a co-author to the EIP. EIP-1153 was created on 15th June 2018 by Alexei Akhno, lead developer at Aragon client. The proposal is currently in review status and CFI for Shanghai upgrade. We will have an overview of the proposal in next few minutes with Moody Salem. Thank you for joining us on the show today.
Yeah, thanks for having me.
So this proposal has been under discussion for over 3 years. I'm looking forward to learn more about the proposal and what it has for Ethereum clients and smart contract developers. But before we get there, maybe we can start with a quick introduction. And when did you discover Ethereum? Maybe about your journey in this ecosystem?
For sure. I actually was introduced to Ethereum by just being a Coinbase customer back in like 2017 or 2018. I think they added Ether as probably, I guess, one of the first assets after Bitcoin. And so I really didn't know anything. I just bought Ether, and then I saw from like $10 to like 40. I had used Coinbase. I had used Bitcoin in the past just for like small payments, but never any other blockchain. So I started reading about the Ethereum protocol and the white paper, and as a software developer, it just sounded really interesting to have like a possibility of unstoppable applications that felt pretty novel to me. I think it was at the time pretty hyped up and like, you know, trying to be applied to a lot of things that wasn't a right fit for. But, you know, as a software engineer at the time, like that, like managing servers and managing infrastructure was a huge pain. So I just really connected on that point. Started going to hackathons. I spent a few years working at like Amazon. I worked on the managed blockchain service for AWS, and I just really didn't see like a perfect fit until I found Uniswap, and I worked there for a couple of years. Worked a lot on V3, and yeah, it's been a lot of fun being in Ethereum.
Indeed, starting from consumer to a contributor, it's quite a journey. Thank you for all the contribution. And yeah, without further ado, let's peep in.
Cool. So yeah, today I'm talking about transient storage. So I guess the goal when I talk about this is that anyone who's listening understands that it's not just a gas optimization. And I think if you understand that, like you understand like why it needs to happen and the purpose of it. And because it's not just a gas optimization, it just makes all these new patterns possible that are much easier to work with in terms of like smart contract development. And I expect a lot of protocols to make use of these new patterns, and I'll talk more about that later. And yeah, so just to briefly like recap the current state of things, transient storage is already like it's a concept that already exists in the EVM. And really it's just when you write to a storage slot that has a zero value, a non-zero value, and then within the same transaction, you write a zero back to the slot. So effectively, you've taken a slot that wasn't used, and you just temporarily used it, and you cleared it. So there's no actual disk write that's involved with transient storage. And today, how that's supported is when you clear the slot, you get a large gas refund for the initial S-store, which wrote the first value. So because we have accounting rules for it, it's already a concept that's enshrined in the EVM, and we use it today for most commonly re-entrancy locks. So re-entrancy locks are required to prevent re-entrance, which oftentimes can be the cause of a vulnerability. So they're used all over the place in a lot of contracts. There's a lot of base contracts that just prevent re-entrancy across the different Solidity libraries, like Open Zeppelin contracts. And then we also use it in some other creative cases, like reading constructor arguments from message sender. So we do this in Uniswap v3 to make it cheaper to compute a pool address on chain. And I know some other protocols probably use this. I know another protocol uses transient storage for their L2 to L1 outbox. So like it's also applied for the smart contracts that power L2s. And this is these contracts just handle making L2 state available to L1 contracts. So it's used in a lot of places already. It already exists, and yeah. So here's the most common usage I just mentioned: re-entrancy locks. Typically, you just have some storage variable which you'll set to a non-zero value, such as true. You'll do your contract logic, and then you'll set it back to false. So you'll see this everywhere. This is just a copy from Uniswap v2. This is the constructor arguments thing from message sender. It's pretty complicated or convoluted why we actually do this, so I won't get into it too much. But it's another use case. You can see here we're setting parameters and then we're deleting the parameters. Here's another use case from Arbitrum's code base. So they will set the context of the L2 block when they're sending an L2 to an L1 message, and then they'll send that message. So if it already exists, what's the problem? Why EIP-1153? So there's a lot of problems. Firstly, this storage refund I mentioned earlier is capped to 1/5 of the transaction gas, and that was done in the London hard fork to prevent gas token. Another issue is storage refunds aren't given if you revert. So like, let's say you set this re-entrance lock and then something happens that you need to revert in the transaction, the user won't get the gas refund. And there's an EIP to fix that, but it's just sort of a smell, I'd say, with the current state. And then there's this other issue where your lock may always be 0 if the user successfully interacts with your contract. However, the Ethereum client still has to read from disk to know that it is 0. So that read from disk of the 0 value can't be avoided, even though we always know by the logic of the contract that it will be 0 at the beginning of a transaction. And then also, it's just very complicated. So if you ask a Solidity developer how much some write is going to cost, they're probably not going to be able to tell you, because if you want to figure out what EIPs contributed to it, there's probably 5 or 6 of them, and it's changed over time. And it depends on the current state, whether the slot is dirty, whether it's set to the original value. So the branching logic is at least 2 layers deep, and it's hard to understand. And then one other important, possibly underemphasized point is that because you have to read from storage, transient storage does block parallelism. So you can't run 2 transactions in parallel that touch the same contract if that contract uses a re-entrancy lock, which is in storage. And the reason is the client doesn't know that both transactions can run parallel because they touch the same storage slot, and they have to read from the slot. And it's blocking parallelism, but the other thing that blocks it is self-destruct. So that's just a little caveat. So yeah, the solution is the EIP-1153, which just provides these 2 new dedicated opcodes for this transient region, effectively transient memory region, but we're calling it transient storage. And it's the same as storage, but at the end of every transaction, it just gets discarded. So it's more like memory than storage. And here's a diagram that was posted on the Magician's thread, which I found pretty useful, and I think other people have mentioned they liked it too. So yeah, credit to Pascal for this. You can think of transient storage as more like closer to machine state than like the actual persisted storage region, and I think that's what this illustrates. So let's say you have EIP-1153, like what happens? You can just immediately save billions of gas, and I'm not even with regards to like how much of the refund you're actually getting now, but just with regards to the disk reads, you're saving billions of gas. For anything that was previously regular storage, if you just mark it transient, you're now saving a ton of gas for your users. And so this isn't the final Solidity syntax. It's not even under development right now, but this is how it might look in the future. Just adding a transient keyword to your storage variables that you know are transient. And so, yeah, like I said in the beginning, it's not just a gas optimization. It unlocks new patterns, and this is why I think it's really powerful. So let's talk about designing a marketplace contract. And let's just say it's some contract. You have items that people can buy and items that they can sell to a store contract for fixed prices. You might think this of something like OpenSea Seaport, like as a corollary. Let's talk about how you might design this today. A customer comes to your contract and they want to buy 2 items and sell 1 item. So the way that looks in the smart contract is they might call buy for item 1, and then within the buy, they have to send payment for item 1. And then they call buy for item 2, and then send payment for item 2, sell for item 3, transfer the item, and then receive payment for item 3. This is a little bit awkward for integrators. It's kind of like you go to a grocery store and you have to pay for each item separately. Every time you scan an item, you have to pay for it. It's not ideal because you're doing multiple transfers and multiple calls with value. Really, you just want to like buy and sell them all together and just pay at the end whatever you're owed. Let's just improve this a little bit using today's method. Let's say now you can do batch buys where you say you want to buy item 1 and 2 and you send payment for the both of them. And then you say you want to sell 3 and 4, and then you send the both items and you get the total payment for both of those. So we've improved it a little bit. We've reduced token transfers. We reduced payments, item transfers. But it's also not great. You might want to exchange items 3 and 4 for items 1 and 2. So it's still not ideal because you have to have those funds to buy 1 before you sell 2, etc. You can create this new method called execute orders, which supports this use case, which just combines all the buys and sells and just requires the delta payment and the delta items owed. So this works, but like only for the simple case. Like let's imagine that pricing is dynamic, and when you buy 1 or buy 2, you're not gonna know upfront what the price is. And when you sell 3, maybe you don't want to sell 4 if you have enough money after you sell 3. So like you may want to do something more complicated than executing this batch order. So it's better, but it's still a little clunky for integrators because they can't operate on nets and they can't do anything in between these like buys and sells. Just they can't insert their own logic. Like let's say only sell 3 if 1 and 2 are cheaper than etc. So it's better, but not quite easy to work with. So let's talk about how this can be better in future protocols. So instead of enforcing these invariants, for example, when a user buys item 1, you need to immediately collect payment for item 1. And so instead of enforcing that invariant that you've collected payment for item 1 as part of each operation, you can create this overarching operation called lock or open or enter, just other names for this operation. And then this marketplace contract calls back into the customer, sort of with its open register. And now, while the customer has the register open, they can call buy as much as they want. They can call any other contracts. They can call sell as much as they want. And then only at the end do they have to pay the difference and transfer the items. So they may not even have the item yet. They may be selling other things and then buying from a different marketplace, and then they transfer the item in. So like what's really happening is this accounting is happening in transient storage with this new kind of contract. But it does require a lot of transient storage to keep track of this state. So like the refund is a huge blocker to this pattern because it's limited to only 1/5 of the gas that's used in the transaction. And so at the end, you after the user has done all these operations, you check that the balance is settled. And if not, then you revert. Otherwise, you continue, and the user is happy with their order. And so I'm calling this the till pattern in conversation because the contract sort of acts like a cash register or a till, and you're just checking, you're just running invariance on the total value of the till, and you can sort of defer all the validation and token transfers until the user is done interacting with your contracts. It's just another way to remember it, until. So yeah. And the current state, as was mentioned earlier, it's CFI for Shanghai. It's tracked into the Shanghai spec and on a Uniswap GitHub project board. There's some links as well. And yeah, that's all I got. If you have any questions.
Awesome. First of all, congratulations for the proposal into CFI for Shanghai, and thank you for sharing the overview. I think marketplace as the use case will intrigue many dev, and the release of this episode will help the community to set expectation with this upcoming upgrade and learn what's in it. Moving on to the next section, Q&A. About this proposal in simple words, can you maybe explain the advantage of using transient storage over memory and storage slot for application developers especially?
Yeah, so the advantage over using memory is pretty clear. It's that the memory is only accessible within the current call frame. And so if you want to communicate with the current contract, call frames deep. Let's say you want to call into another contract and you want to remember something that happened before you called into the contract later, then you actually need to use transient storage. You can't use memory for that because it doesn't. There's no way to communicate between call frames for memory besides call data, and these contracts aren't trusted in most cases. So yeah, like a lot of the times where you're using, re-entrancy locks or anything like that, it should already just be transient. And you're kind of already using transient storage. It's just now you can use these new opcodes.
That's good to know. So talking about the communication, maybe if you can explain a little bit more about the problem of interframe communication and how is EIP-1153 be helpful?
Yeah, so when a call comes into a contract, you sort of get this like clean memory region, and so you can write things to memory and you can read things from memory, but like if you call into another contract, they have no access to that memory region. And if you call into another contract and that contract calls back into the original one, you also don't have access to that first memory region. So there's no way to communicate even just with your own contract for like a future call, besides storage used transiently. So that's the S store and S load opcodes, or call data And the issue with call data is that if you're calling an untrusted contract, they have the ability to intercept the call data and send something else that you didn't intend. So you can't trust call data, and that just leaves storage used transiently for this interframe communication, which has a lot of those problems shared in that earlier slide.
Awesome. In the proposal, I read somewhere like it could be useful for future storage design, like Verkle Tree. If you would like to take a few minutes, talk about like how this is going to be helpful. I know it's going to save a lot of gas. You have mentioned it, and yeah, if there is anything specific you want to add here.
Yeah, so this is just from my conversations on Discord and the All Core Devs chat. I think it has implications for the future storage designs. I know, for example, that if you write to a Verkle tree, you never actually remove the leaf. So that doesn't necessarily mean that you have to write to the Verkle tree if you're using storage transiently. But there are implications with, refunds, for example. If you have a slot with a value and you clear it, now you have to think about how you're going to change the refunds. And so having this like dedicated transient storage region may mean that we can greatly simplify the refund logic, and as well as the caching logic, if it appears that that's the correct design decision. Something I tweeted about, for example, is right now all the caching logic for storage lives in the client. So if you do one S load of a slot and it's a cold S load, meaning it hasn't been read in that transaction, it's going to cost you 2100 gas. And then if you do a subsequent S load of the same slot, it's 100 gas. So that caching logic is directly written in the protocol, which makes the protocol a little more complicated. It also means that every S load has to be cached, or else that 100 gas may be underpriced. So this could just be pushed up to the application layer. So instead of the client caching every S load, the smart contract may do an S load for the first time it's needed, T store it, and then for future times it's needed, T load it. It also may just S load it once because it's only used once in the transaction, and then the client doesn't have to cache it at all. So it basically just opens up the design space for simplifying storage accounting and possibly making clients more efficient by saving these like caching operations.
That is good to know. We know that it is considered for upgrade, and if this is going to be helpful even for future upgrades when we will have it for Verkle Tree and all. So yeah, that's a good one. Talking about the consideration for the Shanghai upgrade, I'm trying to understand, like for this proposal specifically, it was proposed in 2018 and then was under discussion for some time. Proposal did not move forward. It was moved to stagnant status in 2021 and brought back into active discussion in 2022. Why do you think it is important for Ethereum clients to implement in the first place, and why we cannot get it done with soft fork, getting it implemented at individual time frame instead of having it considered for Shanghai?
Yeah, so I think the reason it's coming up more in recent discussion is because the EVM has changed in a way that detriments the transient usage of storage today. For example, before the London hard fork, the refund was capped at 50%, not 20%. And so there's a very good reason that it was capped, or the cap was changed to 20%. And that was to sort of internalize, from my perspective, to internalize this like block space elasticity that previously was at the application layer with gas token. And so since there's a very good reason for that change, it should be there. However, it does affect existing use cases of transient storage in a way that makes it unusable for these use cases. And I think it sort of brought up some of these like technical debt issues with transient storage. And I think the reason it should be fixed earlier rather than later is that people have to rewrite their contracts to make use of it. Transient storage has been around for a long time, and the way you use it is with Nestor. And so contracts need to migrate; they need to be rewritten before the transient use case of storage can be deprioritized by the client developers. For example, there's a lot of usage on Uniswap v2, a lot of usage on Uniswap v3. If one day the transient usage of storage refund is deprecated or removed with like the Verkle Tree upgrade, that may make Uniswap v2 much more expensive. It may make clients less efficient. So just having more time for contract and app developers to move to the new opcodes is very valuable.
Yeah, that makes a lot of sense. So as we are clearly seeing that obviously it's going to be helpful for smart contract developers, is there any security consideration for client developers implementing this in client and maybe for smart contract developers while implementing this?
Yeah, that's a good question. I think for client developers, the security considerations are that this transient storage region can be used to allocate more memory than the current mStore opcodes. And so we ran some numbers for that, and that sort of goes into the gas pricing consideration. And I think it's pretty safe to say that it's not an issue for clients because the maximum you can allocate is on the order of 10 megabytes, which is less than you can do with a malicious mStore worst case use case. So as far as client developers, I don't think I think the security considerations are well known. At the application layer, I think some Solidity developers have brought up that it may make contracts harder to audit, as well as formally verify and statically analyze and decompile. I think my opinion is that the contracts, as far as formal verification goes, for example, the contracts that people are formally verifying are usually already stateless, and so this doesn't make that case any worse. Like formal verification is very rigorous and challenging, and we tried to do some of that with Uniswap v3, and even just doing it for a square root function was quite difficult. So I think the idea that it's going to make formal verification harder isn't very convincing to me as an application developer. And then as far as like, the risk of smart contract developers writing more bugs, it's also the smart contract developers who mostly want this. So I think we acknowledge that there is a risk that we write bugs with it, but it's worth it to us.
Yeah, right. I mean, obviously, people need to be careful about, but when we know what are the areas there where we can pay more attention is helpful. So for smart contract developer, make sure that we are not adding bugs to it. Talking about implementation, I know when this is in CFI, it probably would be considered for DevNet client team testnet for any upgrade. Are you by any chance aware of any client implementation?
Yeah, on this tracking board, maybe I can just pull it up. There are a few. So it's implemented in a PR with Geth, a PR with Besu, and it's merged in Nethermind and Ethereum.js. Aragon said they could take from Geth's implementation, so hopefully that comes shortly after the Geth one is merged. And there's also an EIP-1153 testnet that was started for a Capture the Flag challenge by Vox from Optimism. I can find his Twitter and send it to you later. But yeah, it's there's definitely some work that's already been done and been happening over the past year.
Awesome. And hearing about testnet for 1153 makes it even more interesting and shows your interest in helping out with this proposal. I know the proposal was originally written by Alexei, and you joined to champion and co-author the proposal. I'd be curious to hear your motivation behind pushing this proposal, how and when you decided to join as a co-author and champion for this proposal.
Yeah, so I've been writing smart contracts for Uniswap for a couple of years, and I was focused on some potential future versions of Uniswap, and one of them really stood out, which I think takes advantage of the till pattern as an option. So that made it very clear to me how useful transient storage could be. One of the things I tried early on with that prototype was just instead of running it on the London hard fork, running on the Berlin hard fork just to see the gas difference, and it was massive. So I could see the impact of the EVM change that went into the London hard fork that capped the refunds. And so that brought my attention to this technical debt, which was I didn't have a way to do interframe communication. And so that I think it seemed to me like it was blocking what was very clearly a better design for Uniswap and protocols like Uniswap. So that was what really motivated me to pursue it.
That is good to know. I know many more things came in between 2018 to 2022, which took priority over this proposal. So thank you for jumping in and helping out push this proposal towards final and maybe implemented in the Shanghai upgrade. One last question on this topic is the general feedback. Now that you have contributed to the EIP repository, I'll be interested to hear your thoughts on the EIP process for core proposals in general, like, dislike, any improvement suggestions.
Yeah, I can say, one thing I've mentioned to Tim before is that I think application developers should have a big seat at the table, a big voice as far as the core protocol development goes, at least for the EVM stuff. I don't know a lot about the consensus stuff, but I've been working with the EVM for a long time. And I have an idea of what things are hard or what things are easy. I think, I've seen in the past cases where some EIPs are falling to the wayside, like 3074 is another big one. And I think they can really have a huge impact on the user experience. But they're not prioritized because I think the people who really want it are maybe a little bit closer to the end users who they're serving. And so it's hard to represent that opinion without including these big protocols a little bit more.
I think that's a very valuable piece of feedback. I know 3074 is also up for discussion. I'm not sure if it would be considered or not, but I would agree to the point that there are a few core proposals which are actually helpful to application developers. So yeah, having their thoughts heard is also important while considering any proposal for future upgrade. Well, that's all from our end. And it's almost time to wrap up. Is there anything that you would like to share with the Ethereum community about the proposal or in general?
Yeah, I mean, I think despite that, like it's been pretty encouraging to see that the client teams appreciate the contributions, and I think it's gaining momentum because of all the hard work that people on the Uniswap team have done. I don't want to
Really?
I don't want to come off as gloomy just because I'm mentioning I wish app developers had a bigger voice, but it's definitely it's a very hard problem to move at this scale. So I understand that. I think it's cool that it actually happens. Yeah.
Right. And no, I think sharing is also very important. It's good that you have mentioned that to Tim earlier. He is managing all core dev meetings, so probably that will be discussed in some of the future meetings. But yeah, it's good to know. Moody, we appreciate you taking out time to talk about EIP-1153 transient storage opcodes, which may be expected on the Ethereum mainnet in 2023. On this note, thanks to our channel subscriber for watching and listening to this episode on Shanghai EIPs. Check out descriptions for Shanghai playlist to follow other EIPs and this proposal related links. Should you have any question on this or any other EIP, let us know at ETHCat Herders Discord. Next week, we will be back with another interesting talk. Till then, keep watching, keep sharing your love with Ethereum Cat Herders. Cheers.